Now we're going to do this in reverse. Determine a region whose area is equal to the given limit. Do not evaluate the limit. The idea here is that this is equal to the limit as n approaches infinity of the sum as I goes from 1 to n of some f of x sub I times delta x, where x sub I is equal to a plus I times delta x, and delta x is equal to b minus a over n. Now let's compare the pieces of this sigma expression with the pieces of this sigma expression. I have a delta x here, and over here, the thing that looks like delta x to me is 3 over n. So I'm going to say delta x is equal to 3 over n, which means that b minus a is equal to 3. Cool. For f of x sub I, well, it's the square root of 1 plus 3i over n. And there's a little bit of flexibility here. We could say that x sub I is 3i over n, in which case a would be 0. Or we can say that x sub I is 1 plus 3i over n, in which case a is equal to 1. Let me actually lay these out like side by side. We'll do both of them. If x sub I is 3i over n, then f of x is equal to the square root of 1 plus x, right? Because then x sub I is just replacing the x. And then we would have a going from 0 to 3. Excuse me, x would go from 0 to 3 with a equals 0. We're done there, by the way. If, on the other hand, we say that x sub I is equal to 1 plus 3i over n, that's the whole radicand, right? So then we're saying that f of x is equal to simply square root of x. And then for this one, a started at 1, which means that b is going to be 4. And we would say that x goes from 1 to 4. How can these both be true? Here's our region in the first case. We have a square root function that is shifted to the left by 1 unit. I know that because when x is negative 1, then this is 0. And the region goes on the x-axis from 0 to 3. So we're looking at the area under the function as x goes from 0 to 3. If we're looking at this other case, the region goes from 1 to 4, but we have a square root function that hasn't been shifted. And so that picture looks like this. And it doesn't matter if I shift left and right, it's the same region. The thing we have to decide is, given an expression like this, what's f of x? And then looking at f of x, deciding, well, then what's x sub I? We aren't going to do a whole lot of this. This problem firmly relates area to distance. We have the graph of the velocity of a car accelerating from rest to a speed of 120 kilometers per hour over a period of 30 seconds. That, by the way, is about 75 miles an hour if you care. We're to estimate the distance traveled during this period, and so we need the area under the curve for t between 0 and 30 seconds. I don't know how accurate we need to be. If I knew the application, that might let me know. But without knowing that, we have options. We can say that delta t is equal to 10 or 5, or if you want to get really creative, 2.5, whatever. And then for any choice of delta, we know we can use right endpoints of subintervals to give me the height of the function, or left endpoints of subintervals, or midpoints. I'm going to use midpoints. And with an interval length of 30 seconds and a subinterval length of 10, that means I'm going to use m sub 3. And then I need to estimate the velocity, or the function height, at the 3 midpoints. The first one at t equals 5 seconds looks to me like it's about 50 seconds. At t equals 15 seconds. I'm going to say that height is, let's see, this is 80, this is 100. I'm going to go with 96. I know, it's an estimate. And then when t is 25, I'm going to go with 118. You may think that's completely arbitrary, but I'm looking at the little gap here and the little gap there, and it makes sense to me. Now, those are my function heights, but I have to deal with something here. The units for the vertical axis are in kilometers per hour, and the units for the horizontal axis are in seconds. And so I need to take this delta t, which is 10 seconds, and I need to convert it to miles per hour. So first I'm going to, this is unit analysis. If you've taken chemistry, you know it. 10 seconds here, I'm going to say 60 seconds converts to 1 minute, and 60 minutes converts to 1 hour. And what I'm doing is the unit that I want to get rid of, in the first case seconds, goes into the denominator of that conversion factor so that I can divide them out, and I'm left with 1 over 360 hours. So we're looking at 360th of an hour for delta t. M sub 3 is then going to be like 50 plus 96 plus 118 times 1 over 360. You may get a different result if you use a different delta t, or if you use left endpoints versus right endpoints. This is really about the process. I get that this is approximately 0.73. Now, the units, 50, 96, 118, they're the output units. They're in kilometers per hour. And then 1/360th was in hours, right? So kilometers per hour times hours is going to leave me with 0.73 kilometers for the distance.